Hello, everyone, and welcome. A couple of days ago, I had the good fortune of interviewing a remarkable lady. Her name is Fanny Mlynarski, and she is Senior VP of Wi-Fi Products at Spirent. And she's also the founder of testing company octoScope, which was recently acquired by Spirent. And we had a great discussion on the importance of Wi-Fi testing and how to get Wi-Fi testing right. So watch the interview here.
octoScope was founded at the end of 2006. I founded it. It was started as a one-person consulting company. So I was a CTO, a wireless CTO for hire. And the consulting business gave me a lot of insight into the market needs. We grew our consulting practice, there were three of us, and we grew our consulting practice to $1 million a year. At which point in 2013, we switched to product revenue. We abruptly ended our consulting practice and switched to product. We had the Octobox developed. We had some early customers, early adopters for it, and that's how the testbed was born.
And tell us a little bit about the need that you saw in the market, the need that you were trying to meet, because at that time, it was a transitional period for the Wi-Fi industry, correct?
Correct. And octoScope was also doing the testing the old way at the time, as were pretty much everybody. We were all walking around inside buildings with a cart and measuring throughput by hand and rotating the cart to get more repeatable results. And try as we might, even with the same exact product, we would test in the evening, come back in the morning, and the results were so different that we could not use them. It's just frustrating. Even a simple test that now takes a minute to run in the Octobox would take a week to run in the office, running around, repeating stuff, and then compiling results by hand.
So this is a result of you working out a way principally to test for multipath. Is that not right? Was that not the original value prop?
Multipath is an important component because it does exist in real life, and it had to be in the test bed. And we had to show and demonstrate the equivalency of the results in the Octobox testbed versus in a typical house.
Right. And this is And this is now the product which is today part of Spirent, as you were acquired. I think, when exactly was that? Was it like 6 months or a year ago approximately?
March of 2021.
March of 2021. So now your product line is part of Spirent. We're super happy, by the way, about that. Spirent is a longtime partner of ours, and we follow them very closely, and you guys do great work. Also, talk to us a little bit about how the need for testing has evolved, because I remember you mentioned to me, and this was a statement that really struck me, that it's actually very much a need that originally came from service providers, that they wanted to make sure that whatever they were providing, whatever they were putting into a home, was of the right quality, and therefore the testing needs were all of a sudden different at some point, right?
Correct. Before the service providers got into this game, there was really no pressure for the NEMs, for equipment manufacturers, to do testing. In fact, if they didn't have to, they didn't do it. Now, for service providers like AT&T and Verizon and Charter, those guys ship tens of millions of access points and extenders as well for the home mesh. And if they ship a bug out into the field, it hits their support lines really hard. It can bring them down to the knees. So the costs are huge. And these guys really need to make sure that they have coverage and performance in the homes.
Right. So this is really the scale of what's going on, and it became all of a sudden ridiculously or crazily important that you get the quality right and you get reproducible test results. I mean, this is really, and before that, it was rather at a different scale, right? So that shift has meant a lot, I guess, to also to Octobus, but to the Wi-Fi industry in general. No?
That's right. There was really no pressure and no incentive to test.
Right.
Right.
Yeah. What would you say? And by the way, I should say now, Octobus, as I said, is now part of Spirent. Your products are part of Spirent, including the special technology essentially that you invented in order to serve service providers. And others as well. What would you say are the most important Wi-Fi tests that anyone in the Wi-Fi industry really needs to think about doing at this time?
Good question. So it evolved. So we started out with some simpler tests, focusing on device testing, which is mostly throughput versus range versus interference, and versus multipath, of course. Then it evolves, and today the emphasis is on coverage and efficiency. Now, what is coverage, right? You can put many APs in the area, I mean, in the space that you're trying to cover. APs are cheap, so just getting your heat map all green is easy. But does that mean your Wi-Fi really works? And it doesn't, because historically we've had sticky clients and we still have sticky clients. What does that mean? That means you're, let's say, in your bedroom. Your client, your phone is associated to the AP there locally. Then you walk over to the kitchen, to your exercise room. Now you're far away from that AP, but your phone sticks to it and it's still associated to that AP. Right. What happens in the air link? It may be sending everything at 1 megabits per second, which means it is hogging the area. Nobody else can get on because everything it's trying to transmit is taking that much longer on the air. So it's a problem, and so the service providers have to manage that, and they can't rely on the clients. They have to rely on the infrastructure to do it. To rely, for example, on that faraway access point to say, I'm kicking this phone out because it's a slow guy in a fast lane. He needs to go to another AP. So there's a concept like load balancing, band steering, and roaming that infrastructure on the Wi-Fi side traditionally didn't get involved in that stuff is now managing.
And can you do most testing in a laboratory environment, or do you still have to go to an actual physical location that is modeled after a home or some other particular enterprise, for example?
You can do about 80% of all testing in a laboratory environment. The other 20% you could do by going out in the field and measuring in the field and bringing it back to the laboratory to replay. That's really the most effective way to do it. So for example, we have a tool called the tracker. You can go in a house, any house, walk around and see all the access points. You can have record the walk. You can bring any client and that recorded walk back into the test bed and replay it over and over and over again in an identical way. Nothing changes except the roaming behavior, behavior of the access points and extenders as they work together synergistically trying to steer that client. And that really gives you the insight into the behavior. That steering behavior is very complex. And in the house, it's nearly impossible to debug it because you have uncontrolled interference. You can't repeat it twice the same way. But in the test bed, you can. Another thing you have in the test bed is embedded sniffers. We have multiple sniffers. We have a technology called synchro sniffers, so we can sniff on multiple channels if the device is roaming from one channel to the other, for example. We can sniff at multiple locations near your root AP and near the second extender, the first extender. All the probes are synchronized, so you put the whole trace together and it gives you an insight into what happened.
Right, so this recording and replaying is really the only way of repeating a task, right, predictably is what you're saying, essentially, because you cannot even properly recreate the same scenario in the wild, is more or less
Exactly.
what's happening.
Exactly.
Yeah.
It's the only way to reliably replay it.
Talk to us also a little bit about testing schedulers, because this, of course, has become a thing, a big thing with Wi-Fi 6. And forward from Wi-Fi 6, everything is gonna in Wi-Fi is gonna have a scheduler, right? And schedulers are not born equal. They or they might be, but there's a lot of things you can do with them, right? So talk to us a little bit about that.
Again, like anything else, they're very complex and they're very hard to test. So you will hear marketing claims of high efficiencies and all the sophistication. How do you know it works?
Right.
So what's a scheduler? As you mentioned with Wi-Fi 6, Wi-Fi 6 access has added OFDMA technology, which means that high efficiency, it means high efficiency. What's high efficiency? If you have multiple phones doing multiple calls, multiple devices playing games on the air, you can put them on the air simultaneously and subdivide the band. But you have one access point which manages who gets on the air, and there is some overhead and interacting and setting up who gets on the air when, how many, depending on traffic. Some stations may request some bandwidth. Let's say you started high definition video streaming and you demand some bandwidth. So all these schedules have to figure out which devices to put on the air when, and from packet to packet, you have different allocation on the air. So the question is it high efficiency? Is it faster? Well, we found in the early days of DMA that it's not, the throughput is actually lower. But then we measured delays with short packets akin to what you would get with audio. And the delay difference is significant. So we have some gains, we have some pretty cool demos of that in the system that are repeatable. And so you can see now where the benefits are of this new complex technology.
And if you just maybe take a helicopter's view and give us the general advice to service providers, perhaps to enterprises, where should they start when it comes to Wi-Fi testing? Now, quality, again, as we already discussed, a huge issue, especially for service providers, but I think for everybody in the industry, of course. So where should they, what is your general advice to them?
So there's a series of tests. In the test methodologies, divide and conquer is a good approach. You isolate the different things you want to test. You can start with device tests. You want to test the routing subsystem of your device. How quickly can it send packets independent of RF, right?
Right.
What is the performance of that subsystem? When you're testing the range, you don't want to stress too much that routing because you want to know, you want to isolate these aspects, right? And now you need multipath and interference, and you want to see where you disconnect. You want to start increasing the loss, see what the performance is, that's rate versus range. You want to test it over orientation, you want to spin things or test at different positions to see the antenna pattern of the device. And that's just a device test, okay? Then you get into more complex system tests. Like what I mentioned, do you really have coverage, right? Does your extenders actually help you? Does the root node kick you out or extender kick you out? What is your backhaul bandwidth? You have to isolate that. Extend, so you do a zero hop test. What is the throughput through your root node? One hop test, you first extend the root to the backhaul. Hop test, from the second extender to the first, to the root node out. So you get the idea, right?
Right.
And then you need to add airtime fairness. You need to add more than one device. So there's like, there are hundreds of test cases. And now we see emerging industry standard tests, like from the Broadband Forum, you have 398. You have ETSI now working on a similar standard, and those guys actually put limits in test limits that you have to pass to actually pass it.
So Fanny, when somebody chooses to work with you and work with your equipment, do you provide ready-made test cases? Presumably you do, right? Or
we do have hundreds of test cases that are automated, and over time we have polished them, how they work, and so that is really the value of the system. You don't have to be an expert, because with our automated pre-configured tests, you can be a technician and get trained on the system and just run through.
Fanny, it's fantastic to have you. We're nearly out of time for this interview, but we are going to have you back for the Wi-Fi World Congress special edition, virtual edition, in November, and we're super excited to have you. So much excellent information on testing and how to approach that from you and from Spire. So we're really looking forward to that. But for now, thank you so much for coming on for the short interview. All right?
That's terrific. I look forward to the next time, and thank you for having me.